Degree of a term or polynomial. Degree of a term will be 8 for the first example. And we know that the degree of that term is 8 because we look at the exponent. So let's look at a different example. A different example would be negative 2x to the 6, y to the third, z to the understood first power. We don't see a 1, but we know it's going to be to the first power. So when we add 6 plus 3 plus 1, we get 10. So the degree of this term will be 10. Remember, take note that this is a term, is not a polynomial that has multiple terms in it, although one term could be classified as a polynomial. Now, if we look at the number 8, the number 8 doesn't have an x or any kind of variable next to it. Therefore, we don't have an exponent with a variable. So we know that the degree for just a number alone is 0. Now let's look at the degree of a polynomial. Take note that this right here is our first term. So we have first term right here. And then we have our second term right here. So we'll put second term. And then we have a third term. Third term. It's very important to understand what a term is. And terms are separated by typically our plus and minus. So right here, our yellow is 2x to the fifth power is our first term. And then we have 2x to the 6, y to the third, z is our second term. And then we have x to the fifth, y squared, z to the fourth is our third term. Okay, so we can identify each degree for each term. So we'll start with the first one. We know that the exponent is 5, so our degree for that first term is 5. Now let's look at the second term. Well, we have 6, 3, and 1. When we add those, the degree for the second term is 10. Now let's look at our third term. We have 5, 2, and 4. These are all exponents for variables, and we add them together. That's 7, and 7 and 4 is 11. Okay, so we have to pay close attention to this part where it says highest degree of terms. So whenever we're finding the term of a polynomial, so that's our poly, and written out as a degree for our polynomial, you have to remember that you need to take the highest degree of terms. And so we'll look, is it 5, 10, or 11? And the highest value is 11, so our degree for our polynomial is 11. When we're finding degree of a polynomial, keep in mind you do not add the degrees for each term. You'll simply take the highest value, which is 11. Okay, that's whenever we have separate terms. When we have one term, if you look on the left side, when we have one term, this is just one term. That's when we do add the exponents together to get a degree. So let's look at a couple of examples. Let's look at example number 1. Okay, I know that since I have an exponent of 4, my degree for that term is 4. And then I have an exponent of 3, so that's the degree for my second term. And whenever I am asked for the degree of the polynomial, I simply take the highest number, which is 4. Okay, let's look at number 13. I have this term, the exponent is 4. So our degree for that term is 4. Then we have this term, which is 5 into the third. Our degree is 3. Then we have negative 2n squared. Our degree is 2. And then right here, we have 8n to the first power. So then we think, okay, which one is our highest value? And our degree will be 4. If we look at 14, we have This degree for 9v to the 7th is 7. Remember, we're only looking at our exponents. So this degree is 6. The following term is 4v cubed, so our degree is 3. And since we have no variable with -1, our degree is 0. Okay. And now that we have collected all the degree values for each term, we're going to get the degree for the polynomial. So when we're asked for the degree of the polynomial, it's simply 7. Because when we go back, remember, when you find a degree of a polynomial, it's the highest degree of terms.